If you're confused, the area that you're required is this area, shaded region representing the area, right? Now what you need to know is there's no such thing as parametric equation integral. What you just write in what you do in secondary school, you will do this required area. Actually, it's just you know that this is from xq to xr y dx. Am I right? This part here, now what you need, your whole goal in parametric, right, is to change this to in terms of a function of d theta. We know that, and d theta. Now every year, millions of marks students will lose it at this juncture here. This juncture is very important, very important, very important, very important. Remember this, very important, When this is dx, this is x. All these are x value. So when you change your definite integral, remember to change to parameter. Remember that, This one every year students will die one. Just make sure you change to in terms of theta. Okay? So what we're gonna do is, let's do it slowly. This part here. This will be y. Y is a 1 minus cosine, right? So a 1 minus cosine theta. Then dx d theta, because x is we need to differentiate our x a d theta minus sine theta here. So dx d theta is a1 minus, differentiate sign is cosine theta. So this one, remember, you treat this as entity. Of course, this is dx equals to a1 minus cosine theta d theta. Your school will say, cannot write this. Please erase it out after usage. Only one time disposable, okay? Use it once, then just throw it away. So then once you're done already, you'll be a1 minus cosine theta d theta. Okay, remember this one. Remember this one. This one important. This one important, This part is important. This is how you see it. When x is equal to xq, the corresponding point for q is this parameter. Do you see that? This is invisible force here. So xq will correspond to beta. xq is beta is here. Maybe I should use a red color so that you remember forever. So this is beta theta. Then this one over on top will be 2 pi minus beta. So this is 2 pi. Okay, here. Here will be, make a square outside. So a square. Beta 2 pi minus beta. This will be 1 minus cosine theta square d theta. Pretty okay. Then expand it. Remember, for trigo integration, you only have that few expression you can integrate. Sine square theta. This one here, what you need to do is you need to down the power, because you can only integrate any of the 8 expression, right? So remember, any of these 8 here. So you by any means necessary change to any of these 8. And power of 2, very conveniently, we know is power of 2, right? We know that cosine 2a is equals to 2 cosine square a minus 1. The beautiful thing about this equation here is you can change from a square to a power of 1. So remember, your cosine 2a is beautiful because it sort of mess up our trigo life. So this one here, yeah, cosine 2a plus 1 over 2. Good job. My whole goal is to change to any of the 8 or using cancelling method, but this case here I can just use any of the 8 will be do. Cosine theta plus half cosine 2 theta plus half d theta. Then I'll just do it slowly. Okay, maybe not. Can I just integrate? I think I'll just integrate. Over 2 theta here to here. But what I'm going to do is, because there's a half in front, I'm going to just factorize a half out. That will be here. Half. 3 theta. Then I minus off. So by what we learned in secondary school, we know that okay, there you go. You can use the same thing. You can use the formula. Okay, if you want to. But I just use the identity because if I were to rewrite it, my hand is going to drop off really. So this is like, okay. Okay. You like